Large structures look like solid, substantial shelters, safe, secure. Like a mountain, they're immobile. They're not going anywhere. This is how we feel. But structures are actually under continuous pressure of various forces acting upon them: gravity, wind, temperature fluctuations, precipitation, the load of all the people using the building, and the shifting changes to that load as they move around the building, to name a few. Earthquakes and hurricanes can affect the building. The vibration from nearby construction. What looks like a solid, immobile building is constantly reacting to these different forces, and we can't see it, but it is moving. The taller it is, it may be swaying more, and time is its own unstoppable force. Architects and engineers construct buildings with these loads in mind. This is why we know the maximum capacity for people on the rooftop or the maximum number of spaces in a parking garage. By setting occupancy limits and following them, building managers can prevent undue strain on the building's infrastructure, minimizing maintenance and repair costs. These performance levels are key to understanding how far the building can be pushed and still be within the recommended design parameters. But how do we know the building hasn't been pushed too far? Is it still within the design criteria? Is it behaving as expected? Is there any unseen change that is affecting the building? Maybe we know it has endured big storms. Is it still okay? This is where structural health monitoring is a boon for building owners and managers. When you have stadiums or arenas which are catering to tens of thousands of people gathered together, there are additional considerations. Structural safety. Repeated jumping or moving in unison can increase the dynamic load on the building significantly. Crowd control and safety. Monitoring helps in crowd management by providing data on which areas of a stadium may have been affected by an event. In case of emergencies, this information can be critical for guiding evacuations and ensuring that all attendees are safe. Preventing panic. In the event of an unexpected event, like a small tremor or unexpected structural noise, real-time monitoring can help quickly assess the situation and prevent panic by providing immediate feedback that everything is within defined limits. Optimizing design and maintenance. Long-term data can help engineers and architects improve the design of future stadiums by understanding how structures respond to various loads. But the data also helps to create maintenance schedules, ensuring that the stadium remains in top condition over time. Regulatory compliance. In many regions, regular monitoring of large structures like stadiums is required to ensure the venue meets all safety regulations and standards, protecting both the owners and the public. Along with fire and security monitoring, structural monitoring can provide assurance to building managers. Overall, the safety and well-being of thousands of spectators depend on effective monitoring of the stadium's operational conditions. We'll use the Coliseo de Puerto Rico José Miguel Agrelo in San Juan as our case study. It opened in September 2004 to cater to up to 18,500 spectators at a time for a variety of events, including concerts and sports. As Puerto Rico is prone to earthquakes and seasonally may encounter high winds and hurricanes, and as the Coliseo has been serving large audiences for 20 years and has a duty to safeguard the public and the premises, the Coliseo implemented a Structural Health Monitoring, or SHM, solution in 2023. With Estructura's SHM solution, the Coliseo had various geosig sensors installed across the stadium, which were carefully mapped in Geosig's GeoSmart software. Just as a smartwatch can track your movements and vital signs, the Geosig sensors track the structure's continual and often imperceptible movements. The tailored solution then utilizes GeoSmart to retrieve live data from the sensors. These advanced tools provide valuable insights which can be used in real time or archived for long-term analysis spanning years. This data is delivered through a straightforward, user-friendly web interface that allows the user to intuitively monitor the data and to conduct deep analyses of the structure's behavior. The software includes a 3D model representation that highlights observed exceedances of predefined thresholds on sensor channels, as well as potential impact of those on structural elements. By analyzing the live data, the software can extract crucial metrics such as frequency content and spectrogram, response spectrum, displacement, velocity, and interstory drift. Also, the system is highly adaptable, allowing for the integration of additional sensors to monitor such things as tilt, temperature, wind speed, and direction, for example, which allows keeping an eye on other potential impacts of the structure. Over the long term, the same data shown in the live section are gathered and can be used to monitor trends, detect damage early, evaluate seismic performance, plan maintenance, assess the building's behavior, particularly under high stress during major events, and ensure compliance with safety regulations, thereby enhancing the safety and longevity of the structure. The GeoSig specialist can then customize each threshold using any device connected to the GeoSmart system based on the user's requirements. Color changes will be toggled in the 3D model when the defined thresholds are exceeded. GeoSmart also features a facility to create structural assessment reports or periodical status reports of the facility. These reports can also be sent via email to keep stakeholders informed. Thanks to SHM, we were able to compare data from the excited, dancing crowds who attended 3 Bad Bunny concerts to the crowds for 6 games in a FIBA tournament, where the crowds showed less movement in the stands. The data show that the dancing crowds had much more impact on the building during the concerts. These are the kinds of custom analyses that enable facilities managers to make decisions based on trends. Structural health monitoring and sustainability are closely related in several important ways. Prolonging infrastructure lifespan. SHM allows for continuous assessment of structures, helping identify potential issues before they lead to significant failures. By maintaining and optimizing the lifespan of structures, SHM contributes to resource conservation and reduces the need for new constructions. Resource efficiency. By monitoring the condition of structures, SHM can inform maintenance and repair strategies, ensuring that resources are used efficiently. This can reduce waste associated with unnecessary repairs or premature replacements. Minimizing environmental impact. A well-maintained structure typically has a lower environmental footprint. SHM helps ensure that structures perform effectively, reducing energy consumption and emissions during their operation. Adaptive management. SHM systems can provide data that helps in making informed decisions regarding structural modifications and upgrades. This adaptive management supports sustainable practices by ensuring that changes align with current environmental and societal needs. Disaster preparedness. SHM enhances resilience to natural disasters by providing real-time data on structural performance. This can aid in minimizing damage and improving recovery efforts, which is crucial for sustainable community planning. Informed design choices. Data collected through SHM can inform the design of new structures, allowing engineers to incorporate sustainable materials and practices based on real-world performance data. Life cycle assessment. Integrating SHM with life cycle assessment methodologies can help evaluate the long-term sustainability of structures, guiding decisions that prioritize durability and reduced environmental impact. In summary, SHM supports sustainability by enhancing the longevity and performance of infrastructure, optimizing resource use, and aiding in the design of resilient, environmentally friendly structures. Estructura is a subsidiary of engineering firm Dorado Services, which was established more than 20 years ago. Estructura works in close partnership with Swiss manufacturer GeoSig with the objective of creating awareness about structural health monitoring systems and offering SHM solutions tailored to the needs of the structure. GeoSig has more than 30 years' experience manufacturing precision instruments for earthquake, seismic, structural, dynamic, and static monitoring and measuring solutions. And now, are there any questions?